Today we're working on our first example of a hypothesis test for one population proportion in the chapter Analysis of One Categorical Variable. So when you look at these paragraphs, there are a few pieces of information that you're interested in. You're always interested in the sample size. So here we have 852 Americans. Then you're interested in the number of successes. So here 403 people said that they do not floss their teeth. We need to know alpha, so that will help us to make our decision. And then we also need to know what we want to show. So here we want to show that it's more than 50%. And then we also need to have information on our parameter definition. So that includes the population. So here our population is Americans. And then the success is if they say that they do not regularly floss their teeth. So that information is going to help us perform the rest of the hypothesis test. So we'll start with the population, and here we said that our population is Americans. Then we would state the sample, and here we have 852 randomly selected Americans. And then, just like I did for confidence intervals, I've added in for step one, defining your parameter. So our parameter here is still P, so we're interested in making an inference on one population proportion. And these always start with percent or proportion or probability depending on the problem. Here we have a percentage, so I'm going to say percent. Then you would state the population, so it's going to be percent of Americans, and we decided that was the population up here in letter A. And then finally you would state the success, so we consider it a success if they say that they do not floss their teeth regularly. Okay, so that will help us to make our interpretation or inference at the end, and this also helps us to know what we set our sights on for the rest of the hypothesis test. So then we have to write both the null, and the notation for that is H sub O and colon, and then we write the alternative. So for both of these, because we're going to be trying to make an inference on P, the notation we use is P. And then when we look at our paragraph, our goal is to see if it's more than 50%. So that actually is going to be our alternative. And you could write that as greater than 0.5, or you could write 50%. I prefer to use the decimal value because that's how I will actually use it down here in my calculations for the test statistic and conditions. So then the corresponding null is going to be less than. And remember that the null hypothesis always has the equal sign, so it always be less than or equal to here. Not always less than, but it always has the equal sign. So because this is greater, that will be less than, and then because it's the null, we include the equals. So that's the null and alternative. And then just like we said for confidence intervals, we will always have the assumption that the sampling distribution is the normal distribution. So for the sampling distribution of p hat, we expect that to have the normal distribution. And then here our conditions are slightly different than they were in the confidence interval than they were for the confidence interval. So remember here it's n times p sub 0 and n times 1 minus p sub 0. Both have to be greater than or equal to 10. So n, we saw at the top of the page, was 852, and p sub 0 is actually what we call our null value, so we would use 0.5 there. So then n, which is 852, times 1 minus p sub 0, which is 0.5, we need to know if those two values are greater than or equal to 10. So here we have same number, but just so you can see, we have 426 for both of those. So because they're both greater than or equal to 10, our conditions are met. Essentially, that just means that we're verifying the normal distribution, and therefore the formulas we use are legitimate. So next we're going to calculate our test statistic, and since we're on the normal distribution, we're using a z-test statistic. Now, the formula for this is p hat minus p sub 0, which remember we call the null value, over what's referred to as the null standard error. So here's our formula. Some of these values we can fill in. So we know p sub 0 is 0.5, and we know that n is 852. I'm just missing one number, which is p hat. So p hat, if you recall from quite a few lectures ago, is x divided by n, or the number of successes divided by the total number of trials, or the sample size. So we come up with a p hat value of 0.4730. So now we can calculate our test statistic. I'm going to start by calculating the standard error, the lazy way, where I don't have to figure out where the parentheses are. So that's standard error, and then I'm going to take my numerator, so 0.4730 minus my null value, divided by, and I'm just going to draw what my standard error was from the row above, so that I don't have to do any retyping or rounding. So my test statistic is negative 1.58. Now, the test statistic distribution is the normal distribution. So with that, we're actually going to draw the curve. And these curves, as we learned, are centered at 0. So we'll put our test statistic on the curve. And then because my alternative is more than 50%, I actually am interested in the area above my test statistic. So I need to figure out what this area is. To do that, we're going to use the calculator's normal CDF function. And all I need to tell it is what my lower bound is. So here it's negative 1.58. And technically, if you remember from a few handouts or lectures back, that goes up to positive infinity. So for all intents and purposes, we're going to put in 999, and then you leave these two values as they are, so 0 and 1. So this essentially is going to tell us what that area or probability is on the inside there. So we find a p-value equal to 0.94. So we want to know if the p-value is less than or equal to alpha. So we need to know if 0.94 is less than or equal to 0.05. So the reason we want to know that is because this would indicate that our null value is far enough away from our sample value to indicate that the null value is incorrect. However, it appears here that our null value isn't that much different from our sample value, and so because of that, we're going to fail to reject the null 0.5. So because we fail to reject, our beginning portion of step 5 will be that there is insufficient evidence. So insufficient always goes with fail to reject, to suggest, And then we're going to essentially restate our alternative in words. So step 5 addresses the amount of evidence you have for the alternative, and step 4 addresses your decision on the null. So that's why in step 5 we'll actually restate this alternative. We'll just put it in word format. So we had defined P as percent of Americans who do not regularly floss their teeth. So we're going to say there's insufficient evidence to suggest the percent of Americans who do not regularly floss their teeth. And then we wanted to show that it was more than 50%. And so that's what we're going to finish our conclusion with. So there's insufficient evidence, and we're saying insufficient because we failed to reject, to suggest the percent of Americans who do not regularly floss their teeth as more than 50%. So that's the first hypothesis test example, and for this one we were looking at a more than problem. For the next two we'll do a less than and then a not equal to.